Okay, everyone, welcome back to your Chem 4 lecture. We are diving into chapter 6 today on ions. So to start with ions, then we'll learn how to name ionic compounds. Then we will talk about molecular compounds and how to name molecular compounds. This is a long one, so just be kind of aware. This is going to take a lot of practice, so make sure that you're paying attention and take as much time as you need to rewind the video to make sure you understand this lecture material before you move on. And the more practice you get, the better. Okay, so what do we know about ions? Well, atoms don't tend to show up in their neutral form much in nature. And instead, what happens is they either lose electrons and form a positively charged ion, or gain electrons and form negatively charged ions. And the final way that they do that is they transfer and share electrons between multiple atoms. And that's what happens when you form a molecular compound, which we'll talk about towards the end of the chapter. But for ions, we have a very particular type of chemical bond that arises called an ionic bond. And it's very simply a electrostatic attraction. You have positively charged ions that form when they lose electrons. Then you have negatively charged ions that gain electrons, and so they have a negative charge. Now, what happens when a positive and a negative charge interact? They attract, right? They come together. So that's what an ionic bond is. It's just you have these very small ions that are forming electrostatic attractions. Molecular compounds we'll talk about in a little bit. Okay, now what are the rules for ionic and covalent bonds? Well, let's go ahead and talk about what's called the octet rule. When atoms lose, gain, or share valence electrons, they tend to acquire an octet of 8 valence electrons. In other words, they want to look like their nearest neighbor noble gas, either by losing electrons to get to 8 valence electrons, or gaining electrons until they have 8 valence electrons. Ionic bonds are when these valence electrons are transferred from a metal to a nonmetal. And covalent bonds form when nonmetals share valence electrons. So this is an example of a transfer here. A metal gives up its electron, it forms a positive, what we call a cation, and the nonmetal gains that electron, forms an anion, or a negatively charged ion. Then these positive and negative charges attract each other. In a covalent bond, this is where 2 nonmetal atoms come together, they share electrons, and then that allows them to reach their full octet. So looking at the metal ion here, we see that it gave up 1 electron and now has 0 valence electrons. That's another way that you can see, oh, this looks like its nearest neighbor noble gas. It's lost all of its valence electrons. Now the nonmetal has 8 valence electrons, so it also looks like its nearest noble gas. Okay, so what happens with ionic? Why is it that metals form positive ions? Well, the metals in group 1A, 2A, 3A all have very low ionization energies. That means it takes a very little amount of energy to remove an electron and form a positive ion, if you'll recall from our discussion in the previous chapter. They will lose those valence electrons to form an ion with positive charge. And again, they're going to lose electrons until they resemble their nearest noble gas. For sodium, for example, sodium's nearest noble gas is neon, which is 10 electrons. Sodium has 11 electrons. To get to 10 electrons, obviously, it has to give 1 up. If you look at sodium's electron arrangement, you'll see that it has 1 valence electron. So if it gives up that 1 valence electron, that means it's left with a stable shell of 10 electrons that matches neon. So that gives us the sodium ion, which is a +1 charge. Looking at the group 2A metals, starting with magnesium. Well, magnesium has 2 valence electrons. Again, its nearest noble gas is neon, which has 10 electrons. In order to look like neon with the 10 electrons, it has to give up its 2 valence electrons, and that leaves it with a stable shell of 10 electrons, and because it has 12 protons, a 2+ charge. So note, again, we write the charge as a superscript after the symbol of the element. Now, nonmetals, on the other hand, have very high ionization energies. So they don't want to give up their electrons to form positively charged ions. Instead, they're going to gain electrons until they resemble their nearest noble gas, which is going to be 8 valence electrons. For example, chlorine. Chlorine has 7 valence electrons. And in order for it to look like its nearest noble gas, argon, it can gain 1 electron and get 18 electrons. And that forms what we call the chloride ion. So, so the other way you can look at it is just look at the valence electrons. Chlorine has 7 valence electrons. In order for it to have a filled octet of 8 valence electrons, it just needs 1 extra electron. That's the dot that would go right here. So it gains an electron, boom, it has its stable octet. Now, because it has 18 electrons compared to its 17 protons, that also means it has a -1 charge. Okay, so just to give you an idea of these common ion names, for the cations, the metals that is, when we name the cation, it's the same name as the element followed by ion. So the lithium plus ion is just called the lithium ion. Sodium plus is called the sodium ion. Potassium with a +1 charge is potassium ion. Same thing with group 2A and 3A. Magnesium with a 2+ charge is the magnesium ion. Calcium with a 2+ charge is the calcium ion. Barium with a 2+ charge is the barium ion. Finally, aluminum in group 3A forms a 3+ charge ion. So that's the aluminum. Now the naming changes a little bit when we form our anions. There, instead of using the name of the element, nitrogen, so nitrogen gains 3 electrons because it has 5 valence electrons. So to look like its nearest noble gas, it needs 3 electrons. So when we name these nonmetal anions, what we do is we drop the end of the compound or the element's name and replace it with IDE. So nitrogen becomes the nitride ion. Phosphorus becomes the phosphide ion. Oxygen becomes the oxide ion. Sulfur becomes the sulfide ion, the 2- charge. Same with oxygen there. All of the halogens become a -1 ion. So fluorine becomes fluoride. Chlorine becomes chloride with a -1 charge. Bromine with a -1 charge becomes bromide. And iodine with a -1 charge becomes iodide. And this is how it looks on the periodic table. This is one reason that we focus so much on the representative elements, is because we can see the patterns with the ions that they form really clearly when we look at the periodic table. So note group 1A always forms a +1 ion. Group 2A always forms a +2 ion, and group 3A forms a +3 ion. Group 5A always forms a -3 ion. Group 6A elements form a -2 ion, and group 7A always form a -1. You can also count the distance from the nearest noble gas in case you ever forget. Like fluorine, for example, is 1 away from neon. So you can see, oh, I need 1 extra electron to get to neon. So 1 extra electron gives a -1 charge. Oxygen, on the other hand, needs 2 extra electrons, 1, 2. So that's going to be a 2- charge. Okay, so now how does this link to your health? Well, many of these ions are crucial for various functions in the body. Sodium, for example, is the principal ion that's responsible for charge balance in your body. We've got sodium and potassium. Sodium builds up on the outside of the cell, and potassium builds up on the inside of the cell. Being able to have sodium and potassium allows for the function of the sodium-potassium pump, which is one of the biological mechanisms you'll probably learn a lot about in your biology classes. Those are crucial in order for like electrical communication in your nerves and all throughout the body. Calcium is found outside the cell. Calcium is also very important in bones. It's kind of the major cation that's in bones, and also it's used to start muscle contractions. We also have magnesium, just to give an idea, the magnesium ion, which is Mg2+. It's also found in bones, and it's essential for the function of certain enzymes, as well as muscles and nerve controls. And here's some sources that you can get these from. You don't have to memorize these. You probably remember potassium is for bananas. So like, for example, if you're cramping, oftentimes you'll be given like a banana for your muscles. That's to help the flow of nutrients into your cells and in the form of sodium and potassium. Yeah, calcium is present in dairy as well as greens and spinach. And then finally, magnesium you also get from plants like chlorophyll. Okay, so let's go ahead and do the first sample exercise number 1. The sample exercise packet is down below in your lecture discussion. So just go ahead and take a look at that. And let's go ahead and write the first word. So what I want to see is give me the formula and symbol and go ahead and name ion that has 16 protons and 18 electrons. So it doesn't say it here, but I want you to name it as well. We'll go over the nomenclature again, but for now, go ahead, pause the video, write the symbol of the ion that has 16 protons, 18 electrons. Give it a shot. Okay, we're back. Let's go ahead and look at the answer here. So 16 protons identifies the element as sulfur, right? So symbol S. The fact that it has 18 electrons means that it has a 2- charge. 16 minus 18 is -2. So the ion is S2-. To name it, it's an anion, so it's a nonmetal. So we drop the end of it, which is and then we put an IDE. So that becomes the sulfide ion. Okay, so look at calcium and chloride. I go ahead and identify each as a metal or a nonmetal. Give me the number of valence electrons in each of them. Give the number of electrons lost or gained to form an octet. And then give me the symbol, including the ionic charge and the name of each resulting ion. So go ahead and pause the video. Let's work this out. What ions does calcium form? And what ions does chlorine form? Pause. Okay, let's assume we're back. Walking it through here, calcium, it's on the left side of the periodic table, that's a metal. It's in group 2A, so it has 2 valence electrons. The number of electrons that must be lost or gained, well, it has 2 valence electrons. That means it's going to give up those 2 valence electrons to form an octet. In other words, a stable ion. So it loses those 2 electrons to look like its nearest noble gas. And then we'll look at the symbol here on the next page. Chlorine is a nonmetal. It's on the right side of the periodic table. It's in group 7A. It's a halogen, so it has 7 valence electrons. In order for it to have 8 valence electrons, it needs to gain 1 more, which would give it a -1 charge. Okay, now let's look at the symbols here. So calcium forming a 2+ ion would give us calcium 2+, and it'd just be the calcium ion. Chlorine forms the Cl- ion, which is chloride, with a chloride ion. Okay, now we're going to look at how these cations and anions combine to form ionic compounds. And then we're going to understand how to write the chemical formula. Okay, so how do ionic compounds form? Well, we know that ionic compounds have positive and negative ions that are attracted to each other through electrostatic attractions. In other words, the positive ions are attracted to the negative ions and vice versa. These are what are known as ionic bonds. They tend to have very high melting points, and they tend to be solid at room temperature. Think sodium chloride. Like if you just took sodium chloride and put it in a pan and you try to melt it, your oven's not going to get hot enough to melt the sodium chloride. It has an extremely high melting point. So let's go ahead and look at sodium chloride. So we know sodium chloride as table salt. And if we look at sodium chloride here, you can't really see it. Let me see if I can actually zoom in a little bit. There we go. There we go. Okay, so when we zoom in on sodium chloride, this is the microscopic view. So this is what we see, the microscopic view, submicroscopic view. What we have is we have a 3-dimensional arrangement of sodium ions surrounded by chloride ions, and those chloride ions then surrounded by sodium ions. So we know there's no 1-to-1 unit here of sodium to chlorine. Instead, it's like they're all attracted to one another. Like this chloride ion, is attracted to this sodium ion, this sodium ion, this sodium ion, this sodium ion. There's another one at the back, and there would be another one on the front. So it's surrounded by a total of 6 sodium ions that you could say it's bonding to. It's participating in an ionic bond. Looking at the sodium ion, the smaller one here, it's surrounded by this chloride, this chloride, this chloride, this chloride. There's another chloride in the back, and there would be another chloride in the front, for a total of 6 chloride ions that one sodium ion is participating in an ionic bond with. So clearly, it's a little more complicated than just saying it's an atom bonded to another atom. It's a whole three-dimensional structure built out of these units that all kind of repeat and interconnect. Okay, there we go. Okay, so yeah, that's sodium chloride. Now, how do we write the formula for an ionic compound? Well, in a chemical formula, we take the symbols and the subscripts, and we give the lowest whole number ratio of the atoms or ions that form a net charge of 0. In other words, for sodium chloride, we have a +1 ion combined with a -1. So when you bring one +1 ion to one -1 ion, that gives a net charge of 0. So that gives us a simple formula of NaCl. Remember, the net charge has to equal 0, so the total positive charge has to equal the total negative charge for the ionic compound. Now, magnesium and chlorine, however, can form an ionic compound as well. Now, in this case, magnesium forms a 2+ ion, and chlorine still forms chloride, which is a 2- ion. Well, now, in this case, in order to balance the charge, you need 2 of the -1 chloride ions for every 1 of the magnesium 2+ ions. So the correct formula for magnesium chloride is MgCl2. And the other way can happen as well. For example, sulfur forms a 2- ion, so that's sulfide, right? S2-. Sodium forms a +1 ion. If you have a 2- ion, in order to balance that charge, you need 2 positive. Well, if you get 1 sodium, that's only 1+, 2 sodiums, that's 2+. Now they cancel each other out. So you'd have a chemical formula of Na2S. I hope this makes sense. All ionic compounds have to have a net neutral charge. So the number of positive charges has to equal the number of negative charges. Okay, so let's go ahead and do this together with barium chloride. I'll do it with you here to hopefully help this understand. And then we have several examples as well. Okay, so if we're going to write the ionic formula for the compound that forms from barium and chloride combined, the barium ion and the chloride ion combining, we need to understand the charges. So we have barium, which is 2+. And then we have chloride, which is 1-. Well, if we have 2 positive charges from the barium, we need to have a equal number of negative charges from the chloride. Well, to get 2 negative charges to balance out the 2 positive charges, we have to have 2 of the chloride ions. So in other words, it has to be 1 Ba to 2 Cls, or BaCl2. So that should be our formula, is barium chloride. Now note, we're always going to write the metal before the non-metal in these formulas. So this is the other way you can do it here. You have 1 of the barium ions plus 2 times -1 of the chlorides. That gives 0. Now, if you like algebra a lot, the way that you can think about this problem is your positive charges minus, or I should say plus, the negative charges have to equal 0. Well, we know that we have 1 barium, so that's 1 times 2+. And we know that we have our chloride ion, which is -1. But we don't know how many of them have. So let's just put N times -1. And that has to equal 0. So we need N chloride ions. Well, if we solve for this, we get N times -1 equals -2. Divide both sides by -1. That gives us N equals 2. In other words, we need 2 chloride ions for every 1 barium ion. If you like algebra, that's an easy way that you can do this. All right, so we did that one together. Now I want you to do sample exercise 4. Give me the correct formula for each of the following ionic compounds. Pause the video, and when you come back, we'll look at each of them. So let's take a pause. When we come back, we'll have the. Okay, let's take a look at these answers here. So the first two, pretty straightforward. Sodium and oxygen, it's the sodium ion and the oxide. You have 1 plus charge and 2 minus charges. So you need 2 of the +1 charges to balance the -2 charge, so Na2O. Now, aluminum and chloride, we have Al3 plus and Cl minus. We need 3 of the -1 charges to balance the 3 plus charge from the aluminum, so it'd be AlCl3. Now, here's the hard one, magnesium and nitride. So the magnesium is 2 plus and the nitride is 3 minus. Now, there's no way that we can combine 2 of the magnesiums or 2 of the nitrides to balance it out. So what we have to find is the lowest common multiple of 2 and 3. In order to do that, we can have 3 of the 2 plus charges and 2 of the 3 minus charges to form 6 plus and 6 minus. And that would give us a net neutral compound, magnesium nitride, which would be Mg3N2. I know that one's really tricky, but there's actually kind of there's a kind of a quick way that you can do it as well. I'll just show you this real quick. And I'll show you this with the understanding that there's a big caveat. It's a 2-step process. You can do what's called the crossover and simplify method. The crossover method looks like this. If you take the charges and switch them, so this becomes Mg3 and N2. So the 2 plus comes over here, 3 minus goes over here. That will balance your charges for sure. You'll have a balanced charge no matter what, Mg3 and 2. Now, the problem becomes, let's say that we have lead 4 plus and sulfur 2 minus, sulfide. And here, let me draw in the charges here. So let's say that we have lead 4 and sulfide. When they come together, we would do the crossover method like this. And we would predict that our answer would be Pb2S4. I'm here to tell you that is incorrect. These need to be the simplest ratios. So we need to further simplify by checking to see, are there any common denominators for 2 and 4? You should recognize 2 and 4 are both divisible by 2. So we would need to simplify by going divide both of these by 2. That would give us the correct answer of PbS2. This is what's known as the crossover and simplify method. And again, I'm asking you, well, I'm telling you, when you cross over, you have to also simplify. Just make sure to do that and you'll be fine. Okay. All right, so now we're ready to get into nomenclature. Now I've been doing some nomenclature just as we've been talking, because there's not really another way to kind of solve these problems or talk about these chemicals without being able to name the compounds. But now let's give some formal rules for how to name these ionic compounds. Okay, so when you name an ionic compound, the name of the metal is always written first, and it's the same as the name of the element. So the sodium in sodium chloride is the same as the name for sodium, right? Now, the non-metal ion, assuming you have a non-metal anion, is the first syllable of the non-metal name with the IDE ending. And I already told you this before, but it's always good to review. Chlorine, when it picks up an electron, forms the chloride ion. That's why sodium and chlorine combine together to form sodium chloride. And yeah, just note there's still a space between the names here. So for example, potassium ion and iodide ion form potassium iodide, which we know as K plus and I minus, so it's got to be Ki. Magnesium and bromide form magnesium bromide, and then aluminum and oxygen form aluminum oxide. Should be pretty straightforward, but of course, there's a lot of knowledge that we've built up even in this lecture that goes into us understanding what we're talking about here. For example, when we say aluminum oxide, we know what the formula is from just the name aluminum oxide. Aluminum always forms a +3 ion, So we have to know aluminum is Al3 plus. Oxide means it's the O2 minus ion. So Al3 plus and O2 minus, when they combine in an ionic compound, it's got to be in a 2:3 ratio to have a net neutral charge. That gives us the compound Al2O3. Okay, now let's see if we can do this together, and then we'll have our sample exercise. Let's name the ionic compound K2O. You can even do it now if you're feeling confident. Go for it. So when we name the ionic compound K2O, first up, let's identify the cation and the anion. Well, the cation is clearly the metal potassium, K plus, and it's a potassium ion. Anion must be the anion of oxygen, which is O2 minus. Then we name the cation by its element name, that's potassium. Name the anion by its name, minus the last syllables, plus IDE, that becomes oxide. Then we just put those two words together, it becomes potassium oxide. Okay, go ahead and give it a shot. You've got CaO, Al2S3, MgCl2. Now, this is not in your, I don't believe this one is in your sample exercises, but go ahead, give it a shot, think it through, and can we name this out together? You can pause the video now if you want, or I'll walk you through as we talk about it. So for example, CaO. CaO is a combination of Ca, which is calcium, which forms a 2+ ion, and O, which is O2 minus, which is oxide. So the name for CaO should be calcium oxide. Al2S3, that's a combination of a metal and a non-metal, so it's an ionic compound. The aluminum, aluminum forms an Al3+ ion, and sulfur forms the 2- sulfide ion. They combine in a 2:3 ratio. That's aluminum sulfide. Finally, MgCl2. Mg is magnesium, forms a 2+ ion. Cl is the Cl- chloride ion. So the correct answer here is magnesium chloride. Okay, and there's your solution for it. I guess I should have said this already. So step 1, identify the cation anion, calcium and oxide, aluminum and sulfide, and magnesium and chloride. We put it all together, calcium oxide, aluminum sulfide, magnesium chloride. Okay, finally, we're ready for sample exercise number 5. Give me the formulas and the names for each of the following compounds. So the way this works is, this is a little chart. We've got sodium and aluminum as our cations. Then the sodium is going to combine first with bromide, then sulfide, then nitride, or N3-. I shouldn't have said those names. Oh, man. I got to take it back. Pretend you didn't hear that. This element is going to combine with this one, and this one. And then this element will combine with this one, and this one. So I'll do the first one with you just to kind of help you get started here so that I can hopefully understand what I'm talking about. So first up, we have the sodium ion, Na+, combining with the bromide ion, Br-. When they combine, it's a +1 charge with a -1 charge. So it's going to be in a 1:1 ratio. So it should be NaBr, just like that. Now we need to name it, right? Well, this is the sodium ion. This is the bromide ion. So the name should just be sodium bromide. Okay, now why don't you go ahead and do that for the other 5 blanks here, and then we will look at the answer when we come back. So go ahead, pause the video, and when you come back, we will do the answers together. Pause. Okay, let's say that we're back now, and let's go ahead and go through the answers. So sodium combines with sulfide. To balance the charges, you have to have 2 of the positive charges for every 1 of the 2- charges. So that's Na2S, and that is a compound called sodium sulfide. Okay, when it combines with N3-. N3- is nitrogen as an ion after it picks up 3 electrons. That's nitride. So you have a 1+ ion with a 3- ion. You need 3 of the positive charges to balance it out. So it's got to be Na3N, or sodium nitride. Then we do the fun one down here, aluminum. Aluminum combines with bromide. You need 3 of the negative ions to balance the 1 3+ ion. So AlBr3 is aluminum bromide. When it combines with sulfide now, we need 2 aluminum ions for every 3 sulfide ions for a net negative charge, net 0 charge. That forms Al2S3, which is aluminum sulfide. Then aluminum and nitride, they cancel each other's charges out perfectly. So it's just ALN, and that would be known as aluminum nitride. Okay, so far so good, right? I mean, most of these names are pretty obvious. Now we're getting into some territory that's a little tricky. So make sure you're paying attention. So there's 3 more elements that have exactly 1 ion, which is zinc. Zinc always forms a 2+ ion. Cadmium always forms a 2+ ion. And silver always forms a +1 ion. So those are the transition metals that we always know their charges. All the other ones have a variable charge. Now, this means that copper, for example, can form a +2 ion or a +1 ion. So this can get confusing, right? When we need to be able to represent these coppers in ionic compounds, we need different ways that we can designate it. For copper being either 2+ or 1+, the way that we represent that is we show a Roman numeral after the name of the element with the total of the charge. So Cu2+ becomes copper followed by the Roman numeral 2 in parentheses. Cu with a single positive charge becomes copper with a 1 in Roman. Iron, for example, can do the same thing with a +2 or a +3 ion. Lead can be +2 or +4, and chromium can be +2 or +3. There's many other ions that can form. So cobalt, for example, can form up to, I think, 5 different ions. Manganese as well as a highly variable cation. But these are some examples of metals that have variable charges. Oh yeah, so here's some more that you can see. Let's see, any other ones that we want to talk about here? Yeah, these are all examples of different ones that can form. Okay, now, in this case, that means that we have kind of an additional piece of math that we need to do in order to figure out what is the charge on our metal that can have a variable charge. Well, if we know the charge of the anion, we can then charge balance to determine the charge on the metal ion. Let's look at this example here, MnF2. Mn stands for manganese. So we can look that up on our periodic table. We see it's Mn. So we know it's manganese, and we know it's a transition metal. That means that it could have any number of charges. So we need to determine what that charge is, given just this information, MnF2. Well, F is fluorine, right? So in an ionic compound, fluorine is always going to form the fluoride ion, which has a -1 charge. So if this is the case where we have 2 of these -1 charges, what must be the charge on manganese? Well, we can just do some algebra. If we have 1 times question mark, that's the manganese charge. And we have 2 fluorides, that's 2 times -1 equals 0. That means question mark -2 equals 0, or question mark equals 2+. Okay, so now we know that the element, or the ion, excuse me, is Mn2+. So then we go to name it. Well, Mn2+, that's manganese, right? And it has a 2+ charge, so that's manganese 2. So the correct name for the compound, manganese 2 fluoride. So yeah, here's our little ion charges on the periodic table. This is going to be a way to help us remember, what charges our cations are going to take, and then over here, what charges these take when they're in anion form. Okay, let's go ahead and do an example together, and then we will have some more sample exercises, of course. Like I say, the more you practice this, the better off you're going to be. Okay, so let's go ahead and name the ionic compound FeCl2. Okay, so Fe, what does that stand for? It's iron, right? So iron is not one of our group 1A, 2A, or 3A metals. And it's not the zinc, cadmium, or silver. So that means that it's going to be a metal that has a variable charge. So we, in order to name this compound, have to figure out what that charge is going to be. Well, the way that we can do that is, if we don't know what the charge for Fe is, but we know that when we have 1 of these ions plus 2 of these chlorines, we have a net neutral charge, right? because it's FeCl2, there's no charge there. So it's got to be 1 times the charge of Fe plus 2 times the charge of Cl equals 0. Well, what's the charge on Cl? Cl is chlorine, right? Chlorine always forms a -1 ion. So that means it's 1 times whatever iron charge is, plus 2 times -1 equals 0. Taking it further, Fe minus 2 equals 0. So that means that, oops, Fe equals 2. Okay, that's great. That means that we have a positive 2 charge on our iron. So that means that we have a combination here of iron 2 plus and chloride minus. And sorry, this 2 did not turn out very well. Let's try one more time. 2 plus. Okay, there we go. That's better. Okay, so now we're ready to name. Because we have our cation, we have our anion. Well, what's the name of this cation? Well, it's iron, right? And then in Roman numerals afterwards, we have a 2 plus charge, so we put Roman numeral 2, followed by the name for Cl minus, which is chloride. So the correct answer is iron 2 chloride. Okay, now does that make sense? Does that help out? Of course, you can always ask questions in the comments down below, and I'll answer them just as soon as I can. Oh, oops, yeah, this is how you go through it. Just another way that you can look at it here. Okay, so this one I want you to try on your own. MnO2. Go ahead and give me the name of this ionic compound, and big hint, it's a variable metal charge. So pause the video now, work it out, and when you come back, we will go through the answer. So go ahead and pause it. Okay, let's go ahead and assume you're back. Okay, so MnO2. Well, Mn is manganese, right? And O2, well, O is oxygen. So what do we know here? We know that our metal is manganese. We don't know what its charge is because it's a transition metal. It could be any number of charges. Now, oxygen, on the other hand, as our anion, is really useful because we have oxygen always forms an oxide ion, which has a 2 minus charge. Now, in order for us to figure out the overall charge, well, we have 2 times -2. So we have -4 total charge that has to be balanced out by our manganese. Well, if we have -4 total charge, that means we have to have +4 charge to balance it out. The only place that that can go is on the manganese cation itself. So it's got to be manganese with a 4 plus charge. That's this cation, and that's this anion, this oxide. Okay, well, how do we name it? Mn is manganese. With a 4 plus charge means it's manganese 4, or IV here. Followed by the name of the anion, which is oxide. We get our final answer here, which is manganese 4 oxide. Isn't that fun? It's not too bad, right? Okay. Now, that's a fun part. Now, the other way that we can go is to write the formula from the name of an ionic compound, which I think is a little easy. The way that you can write a formula from a name is you basically take the first part of the name, that's your cation, and then the second part of the name describes your anion. Then you combine them together to make sure that you can balance the charges. That's it. That's all you have to do. It's the reverse of what we were doing before. So let's go ahead and do an example. Let's write the formula for tin 2 chloride. Well, the first thing that we're going to do is let's go ahead and we're going to write out the ions that compose this formula. We have tin 2 and chloride. Tin 2 is tin, Sn, with a 2 plus charge. Chloride, well, that's always Cl minus. Now, how do these come together to form a balanced ionic compound? Well, we have to have 2 of the -1 charges to balance out the 2 plus charge. That would give us SnCl2, like that. And that's how we do it. Not too bad, right? So this is exactly how I do it here. It's the same symbol of the ion. As long as you get the symbol of the ion, then you know that you can combine it to form a net neutral charge to balance your subscripts and balance your charges. Okay. All right, so why don't you go ahead and give it a try. we've got 3 different compounds: nickel 2 sulfide, zinc chloride, and iron 3 oxide. Now I'll point out zinc chloride. Remember, zinc is our transition metal that always has the same charge. So check your notes, check the PowerPoint, and remember what the charge on zinc is always. And then when you come back, we'll look through the answers. So go ahead, pause the video, and we'll be back in a minute. Okay, let's go ahead and pick up here. So for nickel 2 sulfide, nickel stands for Ni. 2 means it's a 2 plus, so it should be Ni2 plus. Zinc chloride, zinc always has 2 plus charge. So zinc always going to be Zn2 plus. Iron 3, iron is Fe. 3 means that it's 3 plus, so Fe3 plus. For the anions, we've got sulfide, chloride, and oxide. No big changes there yet. Sulfide has a 2 minus charge. To balance that, it's 1-to-1, nickel and sulfide. Chloride has a -1 charge, so you need 2 of them to balance your 2 plus charge. And then finally, iron 3 oxide, we have a 3 plus from the iron, 2 minus from the oxide. So we need 2 of the irons for every 3 of the oxides. So that gives us our final answers here of NiS, ZnCl2, and Fe2O3. Not too bad, right? Okay. Now we're going to throw one final curveball at you with these ionic compounds. And I'm sorry, this is annoying, but it is very important to understand. So, okay, polyatomic ions. So polyatomic ions are exactly what they say. It's basically a group of atoms that have an overall charge. So there's some kind of molecule that has gained a charge, positive or negative, and functions as a group rather than as an individual atom. Usually they're going to involve nonmetals like phosphorus, sulfur, carbon, or nitrogen that are covalently bonded to oxygen atoms, and they can have a -1, -2, or -3 charge. Now, almost all of them have a negative charge except for ammonium, which has a +1 charge, and ammonium is NH4 plus. And so it's 1 nitrogen atom bonded to 4 hydrogen atoms. Okay, so examples of polyatomic ions. If you've ever had to put your foot in a cast or some body part in a cast, that cast is made of calcium sulfate, which is something that can dry out and form like a nice hard cast to make sure that you can't move your bone as it heals. Ammonium nitrate is a combination of the ammonium ion and the nitrate ion that's useful in fertilizers as well as in explosives. So these polyatomic ions are everywhere. Okay, now polyatomic ions. The way that you can know the names of the polyatomic ions, there's only one way, and that is you're going to have to memorize them. I'm sorry to say it, but it's the basic way that you can do this is the same as the way I suggested that you learn element names. Make a series of flashcards. Have the formula on one side and the name on the other side, and then be able to flip back to front and front to back both ways as a way that you can answer these, as a way that you can learn these names efficiently. So for example, hydroxide is OH minus. So put OH minus on one side, hydroxide on the other. Ammonium is NH4 plus. So ammonium on one side, NH4 plus on the other side. Now there's some relationships that you can use that will be helpful. Note this 8 and 8 relationship. So nitrate is NO3 minus. Nitrite is NO2 minus. Now look at this. Chlorate, ClO3 minus. Chlorite, ClO2 minus. Sulfate, SO4, 2 minus. Sulfite, SO3, 2 minus. And then phosphate, PO4, 3 minus. So we're going to look at these relationships a little bit more. But again, the best way that you can work on this now is make those flashcards and start working on them as soon as you have a chance. Okay, so here's a few ways that you can help remember the names of polyatomic ions beyond just rote memorization. Step 1 is note that we have a lot of polyatomic ions that end in 8. SO4 2 minus is sulfate. PO4 3- is phosphate, and NO3- is nitrate. When you take away one of those oxygen atoms, the ion has the same charge, and now its name is going to end with an ite, ite. So it's like 8, one less oxygen atom becomes ite. So sulfate at SO4 2- becomes sulfite at SO3 2-. Phosphate PO4 3- becomes phosphite at PO3 3-. And nitrate at NO3- becomes nitrite at NO2-. Now there's some weird ions as well. Cyanide and hydroxide are pretty good examples of this. Cyanide just Cn-. That's exactly what you think it is. It's that poisonous compound that is super famous. Hydroxide OH-, that's something that's very basic. These are ones that you just have to memorize. Now there's another rule that I didn't really explore here, but when you add an H+, which is a hydrogen ion, to a polyatomic ion, you add +1 to its charge and just add the word hydrogen in front of it. So like carbonate, for example, is CO3 2-. When you add an H+ to it, it becomes HCO3-, HCO3-. So you get an H and one fewer negative charge, or a +1 charge, which +1 to charge, way you can think about it. Now this is known as hydrogen carbonate. The old word for it is bicarbonate, but you can just remember hydrogen carbonate. Sodium bicarbonate, for example, is baking soda. Sulfate is SO4 2-. If you add an H+ to it, you get HSO4-, and that is also known as hydrogen sulfate here. Okay. Now, if we expand the ite and ate nomenclature just a little further, each halogen has this type of relationship with its polyatomic ions. We have chlorate and chlorite. ClO3- is chlorate, ClO2- is chlorite. If we take away one more oxygen from chlorite, we end up with ClO-, which is hypochlorite. If we add one more oxygen to chlorate, we get ClO4-, which is perchlorate. So the per adds an oxygen to the 8, and the hypo takes away an oxygen from ite, is the way that you can think about it. And note, these charges all stay the same. They're all a 1- charge. Okay, so now how does this affect us? Well, so one thing I want to do is I encourage you to pause the video here and start memorizing these. Now you'll have your notes obviously for your homework, but you won't have those notes on the test. So eventually you'll want to commit these to your memory. And this is going to be on the quiz as well. We're just going to do nomenclature for the quiz next week too. So basically all of this nomenclature that we're covering this week. So let's see, where was I going? Oh yeah. So let's go ahead and show how to write these formulas for compounds that have polyatomic ions, and then we will explore some different problems here. Okay. So when we're writing formulas for ionic compounds that contain polyatomic ions, we're going to use the same rules of charge balance as before. This time we just need to remember nitrate, we should always know, is the formula NO3 with a -1 charge. So if we have magnesium nitrate, well, magnesium means we have the magnesium ion, which is Mg2+. Nitrate means we have the nitrate ion, NO3 with a 1- charge. Okay, when we bring them together, we know that we need 2 of the nitrates for every 1 of the magnesium ions. So 1 magnesium ion, 2 nitrate ions, that means it's MgNO3 2. Now to represent that we have 2 of these nitrate ions, this goes back to one of the things I said at the beginning of the lecture. This is where we introduce parentheses. So the parentheses go around the NO3, subscript 2 on the outside, and that gives us our answer. So MgNO3 in parentheses 2. Now note, the parentheses are only needed when you have multiples of the polyatomic ion. If you just have 1 polyatomic ion, you don't need to use the parentheses. Okay, so let's go. Oh, shoot. Okay, hold on. Let's back up. Okay. Oh, shoot. Oh, man. Oh, devastated. Uh-oh. Here we go. Here we go. Okay, let's reshare. I just wanted to fix this real quick. because I didn't want to use bicarbonate. I wanted to use hydrogen carbonate. My bad. There we go. Okay. Oof, man, that was close. Okay. So when we're writing formulas with polyatomic ions, let's do an example together. Aluminum, hydrogen, carbon. Well, how are we going to do this? Well, we note that we have aluminum, right? And we know that aluminum as our cation is always going to be aluminum 3+. Now, what about hydrogen carbonate? Well, hydrogen carbonate, we can either remember that carbonate is CO3 2-. Oops. So carbonate, CO3 2-. So plus H plus gives us hydrogen carbonate, which is HCO3 with a 1- charge. Okay, so then we combine aluminum with hydrogen carbonate. You have to have a net neutral charge. 3+ with 1-. That means we need 3 of these for every 1 of these. So our formula should be Al, and then we need 3 of the hydrogen carbonates. So we put HCO3, put that in parentheses, subscript 3 on the outside, and boom, there's our aluminum hydrogen carbonate. Not too bad, right? I mean, as long as you have these memorized, like, it won't be a problem. Yeah, so there it is, Al HCO3 3. Okay, now why don't you give it a shot with sodium phosphate? Go ahead, pause the video here. We'll walk through it when we come back, but I want to see how good you're doing with these here. And remember, this is a sample exercise, so you can feel free to look at your notes, make sure you understand what phosphate is, and then give me the formula for sodium phosphate. Pause the video. Oh, are you ready? Are you sure? Okay, here we go. Sodium phosphate. Well, oops, okay. So sodium phosphate, that means that we have a cation of sodium, which is Na+. Our polyatomic ion phosphate is PO4 with a 3- charge. In order to balance the charges, we need 3 of the sodiums for every 1 of the phosphates. So that means we need Na3PO4. Note again, we only have 1 of the phosphates, so we don't need any parentheses in this case. Okay. Ooh, isn't that fun? All right. Now, how do we name compounds with polyatomic ions? Well, the name is the same for all ionic nomenclature. It's always that we write the name of the positive ion followed by the name of the negative ion. Usually the positive ion is a metal, but of course it could be ammonium as well. It could be a polyatomic ion now. And then finally, the polyatomic ion is usually the anion, and we just write that next. So sodium sulfate, Na2SO4. Iron 3 phosphate is FePO4, and aluminum carbonate is La2CO3 3. Okay, so some other compounds that contain polyatomic ions. We have aluminum phosphate, AlPO4, that's used in antacids. Aluminum sulfate is Al2SO4 3. That's used as an antiperspirant. It's got aluminum in it, so aluminum is really good at blocking your sweat, basically in the armpits. So that's why it's so useful there. And then, yeah, you can look at these here. But basically, you know, polyatomic ions are everywhere. And that's why we want to learn how to name them, basically. Okay, so now we're ready. Sample exercise number 9. This is a big one. Go ahead, give me the correct formula for each of these compounds. We've got aluminum nitrate, copper 2 nitrate, iron 3 hydroxide, and finally, tin 4 hydroxide. Again, I haven't expected you to memorize these names just yet. We'll have a few of these on the test. On the quiz on Monday. But mostly we'll be focusing on the other types of nomenclature to kind of build into these here. Okay, so go ahead, give me the correct formula for each of these compounds. Pause the video. Okay, I'll assume that you're back now. Let's go ahead and take a look. So hopefully you got the correct answer here. Aluminum nitrate, aluminum has a +3 charge. Nitrate has a -1 charge, so you need 3 of the nitrates for every 1 aluminum. Copper 2 nitrate, nitrate's the same, so NO3-. Copper has a +2 charge, so you need 2 of the nitrates for every 1 of the copper 2s. Iron 3 hydroxide, hydroxide is OH-. Iron 3 has a 3+ charge, so you need 3 of the hydroxides for every iron, so FeOH3. And then finally, tin 4 hydroxide. Tin 4 has a 4+ charge, hydroxide has a -1 charge, need 4 of the hydroxides for every 1 of the tins. All right, and give me the names for these compounds for sample exercise 10. Pause the video, and when you come back, we'll look at the answers. We're gonna take your time, go to pause, and we're back. CaNO32, Ca is calcium, NO3 minus is nitrate, so this is calcium nitrate. SnSO4 2 minus. Well, SO4 2 minus is sulfate. To balance that 2 minus charge, tin has to have a +2 charge, so that means it must be tin 2 as our cation. So the correct name of the compound is tin 2 sulfate. All right, a few more here. Sample exercise 11. I think this might be almost it. We're nearing the end of the ionic compound nomenclature. MgSO3, MgSO4, and Pb3, PO32. So let's give it a shot. Pause the video here. Again, refer to your list of names from before, and we will have the answers here in just a moment. Okay, so taking a look here, Mg is magnesium, which always forms a 2+ ion. SO3 2 minus is sulfite, so it's magnesium with sulfite or magnesium sulfite. Okay, MgSO4, ooh, wow, this one has a mistake on it. Sorry about that, everyone. So it's a combination of Mg2+ magnesium and SO4 2 minus sulfate that becomes magnesium sulfate. All right, now here's a good one. We've got Pb3, PO3 2. Well, PO3 3 minus is phosphite, okay? And if we have 2 -3 charges, and we have 3 of our positive charges, that means these leads have to be 2+. It has to be Pb2+ or lead 2. The answer here would be lead 2 phosphate. Okay, last group in here, sample exercise number 12. Name each of the following compounds. We've got A, B, and C. We've got, actually, let's go ahead and we're going to do this as our graded lecture discussion this week. So go ahead, pause the video here, or well, we're going to end the video now. And in the comments down below, I want you to answer sample exercise number 12. In the comments, give me your answers and let me know if you have any questions as well there. Because I know this is a long lecture, but hopefully it was worth it. We learned a lot about how to name compounds, and hopefully we can start to understand how these, how we can talk about chemicals in kind of a systematic way. So that's the goal for today, and that will do it. Until the next time, I will see you very soon. Again, this is a graded discussion. I'm going to put this answer in the comments down below, and that'll be your graded lecture for the week. Okay, so that does it for this lecture. I'll see you very soon. Until then, let me know if you have any questions. Bye-bye.